Hey everybody, welcome back. Our essential question today is how do you write numbers in scientific notation? So you should make sure that you write this essential question at the top of your Cornell note. Anytime we measure anything in science, whether it's your height or the volume of a liquid or the mass, anytime we measure anything, it's really important that you have both a number and a unit. That's a really important distinction. So make sure that you have, in every time you write a number, both the number and the unit. So for example, 66 inches. Inches are my unit there. 15 years is how old some of you are. Years is my unit. Maybe you are running a little bit of a fever and your temperature is 40 degrees Celsius. Those are all units that go along with the number to create a measurement. It's important, the most important thing here is that you have units on every number. You don't necessarily need to know the definition of a measurement as long as you're using units with your numbers. In chemistry, we use some really big numbers and some really small numbers. And often it's a lot easier to write those numbers using scientific notation. So what exactly is scientific notation? Well, scientific notation is when you use the power of 10 times 10 to something. So it has three parts. The first part is called the coefficient. The coefficient is the number before the times 10. This is the coefficient. Because we have this number here in scientific notation. Oops. We have this number here in scientific notation, and it's 6.02 times 10 to the 23rd power. The coefficient is the first part. The next part, let's see if I can change colors. The next part is the times 10. Times 10 will always be the same. Anytime you're using scientific notation, it'll have a coefficient and the times 10, and finally our last part, which is the exponent. The exponent is whatever exponent we're putting on the 10. This is the exponent. So in this number, 6.02 times 10 to the 23rd power, this is a number that really means 602 sextillion, which you see here. It's 602 followed by a buttload of zeros, 20 zeros to be exact. No, sorry, 21 zeros. And we can write that in scientific notation with a coefficient in red, the times 10 in green, and the 23rd as the exponent in grayish purple, I guess that color is. So for your notes, it's important that you have those three parts written down. The coefficient, the times 10, and the exponent. When we're working with the coefficient, remember our coefficient was in red, so let me go back to a nice red. The coefficient has to be a number between 1 and 10. It has to be greater than or equal to 1 and less than 10. So basically, you're looking at a single digit. You're looking at a single digit coefficient. Single digit before the decimal. That's the really important part. It's a single digit before the decimal. Ooh, that's no good. Decimal. Okay, single digit before the decimal. If your exponent is a positive number, it means your number is big, meaning greater than 1. Oops. Your number is greater than 1. If you have a negative exponent, it means your number is less than 1. These are all important things that you need to know. So let me review that again. Your coefficient Your coefficient is a single digit before the decimal. It can have a bazillion numbers after the decimal, but the single digit before the decimal. To have your exponents, if it's positive, your number is greater than 1. If it's negative, your number is less than 1. All right, so say we want to write some numbers in scientific notation. Let's take a look at these two examples here. My decimal is going to go between the 6 and the 3 right there. Oh, geez. Between the 6 and the 3 right there. God bless America. Okay, clearly this is not working for me. It's going to go right here, is where your decimal goes, because we want a single digit before the decimal point. So my 6 is the only digit before the decimal point. And then I need to count. How many spaces do I have after that decimal point? Well, I have 1, 2, 3, 4, 5, 6. You can count that. So my exponent is going to be 6. Okay, since I have 6 digits here, my exponent is a 6. I know that my exponent is positive because I'm taking this number, which is greater than 1, and I'm making it smaller. So this number is greater than 1. It's a big number. And so that means my exponent needs to be positive. Let's do another one. This one down here at the bottom, 94,700. My decimal needs to go right here between the 9 and the 4. God bless America. This is a new tablet and clearly not being the most amazing. Okay, I give up. You see where it goes, between the 9 and the 4. So I have 9.47. All the extra zeros we can leave off. 9.47 times 10, and to figure out our exponent, how many places do we have? I have 1, 2, 3, 4 places, so my exponent is a 4. This number, this whole number, is bigger than 1, so my exponent is positive. Let's do another one. What if I have 0.00000852 and I want to turn that into scientific notation? Well, where's the decimal going to go? You're right. Well, I hope you're right. I'm doing this at home, so I'm really hoping you're right. The decimal's going to go here between the, God bless America, between the 8 and the 5 is, I give up, I think. Between the 8 and the 5 is where my decimal goes. So I have 8.52 times 10. Is my number greater than 1 or less than 1? Well, it's less than 1 because the digit before the decimal is a 0. So I know my exponent is going to be negative. So I know my exponent is going to be negative. How many spaces did I move the decimal? 1, 2, 3, 4, 5 spaces. So it's a negative 5. One of these days I'll get the hang of this. That doesn't look right at all. Let's try that again. So it's 8.5, quit laughing, 2 times 10 to the negative 5th power. That looks better. All right. Oh, hey, look, we have more to practice on. Here's some more practice problems. We'll do some more together. We don't necessarily need to do these. I think that you probably have a good look at it, but we can pause here if we need to. All right, so our next major topic, this would be a great place to skip a line in your notes. Our next major topic is using multiplication and division with scientific notation. When we multiply scientific notation, we have to multiply the coefficients and add the exponents. So let's take a look at a problem that would do that. My problem is here. In fact, I'm going to scribble out the answers so you can't see them. Yeah, I know you can still see them, but whatever. I want to make sure you know how to do this. So let's walk through it. My problem is 3 times 10 to the 4th inside parentheses times 2 times 10 squared in parentheses. So the first step number 1, is to multiply the coefficients. So I'm going to take 3 and 2 and multiply those two numbers together. So 3 times 2. What's 3 times 2? Well, it's 6. That's easy. Okay. My times 10 is going to stay the same no matter what. So I have 6 times 10. It's my exponent that I have to deal with next. So this 4 and the 2 need to be added together. That's my second step, is to add the exponents. So 4 plus 2 is also 6. That's going to be my exponent. Oops. So 6 times 10 to the 6th. Is that what the answer was before? I think so. I wonder if I can erase this. Oh, I don't know. Eraser. Ha! Brilliant. Hey, look at that. It's the right answer. We're so good. Let's see if we can do another one. Oh, wait. I wrote all over that. I'm going to have to erase our stuff again. Okay. Erasered that. Let's copy out scribble out the answer. So you can't copy it. I know you already did. Blah, blah, blah. It's okay. Okay, so I have another practice problem. Again, step 1, I need to multiply the coefficients. Step 1, multiply my coefficients. So I have 2.1 times 4.0. Well, let's say that I can't do that in my head. I can, you probably can, but let's say I can't. Pull out a calculator. Pull out a calculator and use the calculator. So I have 2.1 times 4.0, and that comes out to 8.4. So I'm back here, and 8.4 is my answer there. We always have the times 10. And then I also need to add my exponents. So I'm doing 3 plus negative 7. What's 3 plus negative 7? Well, that comes out to negative 4. So my answer should be 8.4 times 10 to the negative 4th. Let's see if that's true. Eraser. Okay, 8.4 times 10 to the negative 4th. That's how we do multiplication and division. We've got one more thing, or sorry, that's multiplication. We've got one more thing to cover, and that is division. Oh crap, dude. I have to scribble out the answer. Yeah, I know you can read ahead. But I want to do practice. In division, there are 2 different steps. Step number 1, we need to divide the coefficients. And step number 2, we will subtract the exponents. So here, if I want to divide my coefficients, I'm going to take, let me get back a better color. Alright, I'm going to take 3.0 and divide it by 6.0. What's 3.0 divided by 6.0? Well, 3 goes into 6 2 times, so it turns out to be 1/2. But we want this in decimal form, so it comes out to 0.5. Then my times 10 stays the same. It always stays the same, the times 10. Now I need to subtract my coefficients. Top minus bottom. God bless it. Top minus bottom. So top is 5. I have 5 minus the bottom is 2. 5 minus 2 leaves me with 3. Okay, so we think our answer is 0.5 times 10 cubed, or 10 to the third. There's a problem with this. I want to know if you can spot it. The problem here is that my coefficient, I need a bunch of more colors. My coefficient is not less, it is less than 1. It needs to be between 1 and 10. So I need to move my decimal point over. This puts us in a challenge. When I move my decimal point over, I get 5. When I go from 0.5 to 5, am I getting bigger or smaller? I'm getting bigger. Since this side is going up, my exponent has to do the opposite. It has to go down to compensate by however many times I move the decimal. I only moved the decimal point one time, so I need to subtract 1 from my exponent. So I have 10 to the second power. Let me pause here so you can ask some questions. All right, let's see. We don't really need to cover addition and subtraction. Let's just do a couple more practice problems. My first practice problem is multiplication problem. Anytime I have multiplication, I need to multiply my exponents. 8.0 times 7.0. 8.0 times 7.0. That comes out to 56.00 if you do it all the way. But we'll just say 56. That makes life a little bit easier. Okay, so 56. The times 10 always stays times 10. And now I need to add my coefficients. -2 plus -5. Let me write it up here. -2 plus -5. Well, -2, and I basically subtract 5, that comes out to -7. So my exponent is -7. Alright, the last problem we're going to do today is this division problem. When I divide, I need to start by dividing my coefficients. So I have 7.1 divided by 5. I can't do that in my head, so I'm going to get my calculator. Oops. 7.1 divided by 5. That comes out to 1.42. So I have 1.42 times 10. It's always going to be times 10. Now I need to subtract my exponents. -2 and -3. So I need to say -2 minus -3. Anytime I'm subtracting a negative, it's the same thing as adding a positive. So -2 plus 3 comes out to, oops, that's supposed to be an equal sign, comes out to +1. So my answer is 1.42 times 10 to the first power. You had some homework on this. We're going to take a moment to look over your homework and see how you did.